Math prodigies, welcome back to another linear equations video. This one is on parallel lines and why we care about them. Take a look. Alright, so when we talk about parallel lines, you probably know by now that we're talking about two lines that run side by side that will never touch. Now the example most of us have learned is that train tracks example. If you picture train tracks, they run beside each other, but they never touch. Now in our math class, what we care about parallel lines is that they have the exact same slope. And this makes sense if you think of the slope or the steepness of a line. Two lines that run side by side are going to have the exact same steepness, the exact same slope. And two lines that have the exact same slope are going to run through the graph at the exact same angle or steepness, and that means that they're parallel. Now you have to remember that slope is the a value in y equals ax plus b. Why is that important? Well, if we're asked to prove, or we have to prove, that two lines are parallel or they're not, what we have to do is look at the slope. So in y equals ax plus b, that was the a value. The other way to prove that two lines are parallel is to use the slope formula, which we also remember. And whichever way you're going about getting the slope, well, once you get an answer, if the two are the same, then yes, you have parallel lines. And if you have different answers for slope, then you don't have parallel lines. So does it get any tougher about parallel lines in this class? Well, kind of. Now, if you think of any two lines that are parallel, you know that they'll never cross. All other pairs of lines in the world will cross at some point. So usually two lines, unless they're parallel, are going to cross once and only once. Straight lines can never cross twice, right? They would have to turn back and then re-meet somehow, which, although romantic, is not possible with straight lines. They are straight and they stay straight forever. Now parallel lines are different because they'll never cross. They'll run side by side, but they'll never meet or touch. But now picture two lines that are parallel, but that also have the same y-intercept. So we can't really say that these two lines never cross, and we can't say they cross once and only once. What we say here is that these two lines cross at infinite points along the graph. So if you think of the point where two lines cross as just the point where they meet, well, these two lines are meeting at every step of the way. Anywhere you go on the Cartesian plane, these two lines are together. Now this concept is important for you to understand because it's pretty common that on an exam they're going to ask you about two lines. They're going to give you two equations and they're going to ask you, do these two lines cross once, twice, never, or do they cross at infinite points on the graph? Now you got to consider the two equations to be able to answer the question. And to answer this question, you could eliminate the answer twice right away. No two straight lines are ever going to cross twice. But most lines do cross once and only once. Now the other two options, never or at infinite points do they cross, those have to do with parallel lines. Now two lines that never touch, that never cross, we call those parallel and distinct. Distinct meaning that they are different from each other and will never cross. The other type of line, this last option here where they cross at infinite points or they touch at infinite points on the graph, those we call parallel and coincident. Coincident lines are parallel, yes, but they also have the same y-intercept, meaning they touch at infinite points on the graph. Now the only other thing they could ask possibly is like a yes or no type question. They'll give you a couple of equations or some information, maybe two sets of coordinates, and they'll ask you, hey, are these two lines parallel or not? All you're going to have to do is prove that their slopes are either the exact same, making them parallel, or different, meaning nope, they're not parallel. So that's pretty much it for parallel lines. Try and remember those few key points. And they were, parallel lines have the exact same slope. Parallel lines never touch, unless, of course, they have the same y-intercept, in which case they always touch. And specifically, in case you see those words on a final exam, parallel and distinct means yes, they're parallel, same slope, but a different y-intercept, meaning they don't cross. And then parallel and coincident, meaning parallel and the same y-intercept. Two lines, one right on top of the other. So that's pretty much it. Watch the examples on questions that might come up on parallel lines.